Good morning. Data science, machine learning, and big data are buzzwords that have been with us for years now. You're familiar with the stats? Stats like this graph that say the market size of data is projected to grow from $33.5 billion in revenue in 2017 to $92.2 billion by 2026. And this graph that shows everybody's doing it or has at least been shamed into saying they're planning on doing it. And statements like this from Forbes that say the projection for data monetization to become a major source of revenue a major source of revenue as the world creation of data explodes to about 180 trillion gigabytes by 2025. On the other hand, we have also been seeing a lot of less positive stories of data over the years. More and more companies are getting in trouble for improperly using or not properly protecting personal sensitive data. And at this point, everybody's probably sick of hearing about the Facebook and Cambridge Analytica stories. So our approach to data stems from three overarching points. One, even though buzzwords become tiresome, data is a powerful driver of market and organizational growth and performance. Two, data has a dark side that becomes obvious in cases of breach and misuse, and good stewardship and ethical standards of data are imperative. And three, most organizations are still really bad at handling their data. In fact, if you can honestly tell me you're doing a great job with your data, I will buy you a drink this afternoon after the conference. But let's take a quick step back and ask why data is important. The word data is a convenient word, and perhaps too convenient. You hear it, and it completely fails to evoke any of the possibilities carried within its meaning. The word data is also alienating for some people. It sounds technical and abstract. It doesn't sound like it represents everything we're surrounded with and impacted by on a moment-to-moment basis. It makes us think of this instead of this. And as a side note, it's often pointed out that data itself is meaningless. It's, as Clifford Stoll and others have said, it's only by converting data into information and then converting that information into knowledge and finally converting that knowledge into wisdom that it becomes meaningful. And I agree with that. But personally, when I say data, I'm almost always referring to the data itself, as well as the process of converting it and the final outputs, the information, the knowledge, and the wisdom. And I use the words data and information interchangeably, and I will do so throughout this talk. Data allows us to understand the world around us in ways that we ordinarily wouldn't be able to know. And the more deliberately and creatively we use it, the more powerful it becomes. And whether we realize it or not, we're all constant consumers and creators of data. This constant data consumption is firstly passive input. You know, it's hot in here, this flower smells nice, I'm hungry. We observe it as a data input, and then we do something about it as a data output. Next, we get to a point of basic secondhand information. You know, my friend messaged me about a party, or according to this article, there's this thing going on. And this is secondhand because we've received it from another source. It's basic because it comes very easily to us. And we then respond to it or share it, which is a data output. The third level is basic active information gathering. We go to school, we read, we get training, we practice. It's a lot of data coming at us, and then at the other end, our progress generates a lot of information, which is a data output. And at work, we're constantly consuming data, but this is often like normal corporate data, things like email chains, sales reports, budgets, expenses, CRM information, calendars, and so on. And then at the office, our own day-to-day activities contribute to these, which is, again, a data output. And up to this point, this is all individual data consumption and creation. And none of it seems like a big deal in the context of an individual. And this information is important for us to participate passingly in society and the workforce. 3 things to consider. First of all, every step of the way, we're interacting with another person or company. And as the world becomes more digital, every single bit of that interaction is actually stored somewhere and owned by someone. 2, and actually for the second point, we have to shift from a personal mindset to a company mindset. From a business point of view, how much of this constantly created digital information impacts you, and how much are you making use of it? And if you are making use of it or planning to, are you fully aware of how personal a lot of this data is and what you need to do to safeguard it? Data drives performance because every future action is sparked by past information. The better we grasp that information, the better we can use it. And the world is made up of a network of personal interactions. And the more we digitize this, the more accessible personal information becomes. The more we have to protecting it seriously. And while something like 2.5 quintillion bytes of data are generated every single day, organizations are still struggling with data problems from 10 years ago, let alone handling the data challenges of today. And why is it worth getting a handle on these challenges? Albert Einstein once said, "We cannot solve our problems with the same thinking we used to create them." And one way to change our thinking is to reframe our thought process, something Einstein himself was very good at. The other way is to change the inputs, feed our thought process with new and better information. And if organizations want to improve their output, they need to get a handle on this. And to start getting a handle on these old and new data challenges, creative and proactive information gathering is required. And this is 1, finding new ways to use basic information, your existing data, and 2, seeking out new information sources to create a more defined picture of the world around us. So, finding existing ways to use old data, existing data like this stuff. First, you need to make sure it's easy to access and update it frequently. Right now, how long does it take to get some basic information that you need? And how old is the data by the time you get it? Second, combine data sources to derive new insights. So some source joining is best as part of a planned data implementation. Other times, you'll use software that lets you pull things together on the fly. And sometimes it'll be a plain old SQL query or VLOOKUP in Excel. And the point is, data is more valuable in the context of other data than on its own. Analytical models are important because our ability to understand data just by looking at it is limited. On our own, we can do a pretty good job of describing what happened in the past, but data is worth more than that. And as Andy discussed in his talk yesterday, analytical models can be used to make predictions, inferences, and even determine optimum courses of action. And one example of this that I found quite clever is a market intelligence group that took transcripts of corporate quarterly earnings calls and tested them against the Gunning-Fogg index. And the Gunning-Fogg index is a measure of sentence complexity. It basically checks how many multisyllabic words are used. And they then checked this sentence complexity against the financial performance of these companies. And it turns out that CEOs like to use complicated words when they're hiding their poor performance. So rather than applying this knowledge just intuitively one call at a time, the calculation can be run over many transcripts and modeled against historical financial results to generate predictions when the next earnings calls take place. Next step is to visualize and interact with data. Get your hands dirty with it. Ask a question, interrogate the data until you find the answer, which will inevitably spark the next question, and keep going. And finally, use data for things it's not usually used for. In financial services, they like to call this alternative data, which sounds a bit complicated, but it's often just ordinary data that is now used to inform investment decisions and make lots of money. So a classic example of this is a few folks from a hedge fund that watched corporate private jet schedules. And they noticed executives from two companies going back and forth between each other's headquarters. And though those companies had denied rumors of a merger, the investors decided to bet on it based on the data and won big. So that's step one, finding new ways of using existing data. And step two is to seek out new data sources. And sometimes these are not too far away. There may be data within your organization that can add context to what you're using now. But usually you'll need to look outside your organization to find out what else exists that can complete the picture. And a lot of this data has only become available in recent years, data enabled by the fact that our lives are increasingly digital. So this constant and increasing flow of information we've never before had the opportunity to tap into. Data such as foot traffic data from anonymous mobile, or foot traffic information from anonymous mobile data, credit card spend data, IoT device data, events, weather, sharing economy activities, and more. And all of this, the old data in new ways, the external data, the new data streams come together to answer the question, what new inputs will help you ask and answer better questions, make new decisions, and expand your capacity to understand and solve your problems? And of course, that's all easier said than done. It's difficult, time-consuming, and expensive. Reliable sources must be found. Time must be spent to shape the data into a usable format. Careful expertise is required to build the analytical models. These models then must be communicated effectively back to the people who need the information. Software must be used for visualization, as well as the cleaning and the modeling process. And the good news is that because we know this data impacts many industries and people, at CARTO, we've been taking on the effort of sourcing it, preparing it, building the models, and developing the visualization tools to make these insights more accessible. We've also been leading the conversation around data privacy and ethical use. And this is all part of our new CARTO data streams offering that Javi announced in his keynote yesterday. So instead of talking about it further, let's take an actual example and walk through a use case. And for that, I'll turn it over to my colleague and brilliant data scientist, Wenfei.
Okay. Great, thank you, Hannah. So I'm going to walk you through an example of how we can innovate through new location data streams, or as I like to call it, the fun stuff. Or I guess if you're data nerds like us, that's how you like to think about it. So as Hannah mentioned in her talk, here at CARTO, we're thinking about two aspects of location data streams. One is to find creative new ways to use more traditional data sources, and another is to seek out new data sets in order to help us create a better picture of the world around us. So in other words, how do we answer old questions with new data and new techniques? So I'd like to present a fairly standard case study and how we can approach it from a new light. The city of Cambridge, Massachusetts, like many urban areas across the country, has undertaken a Vision Zero initiative to improve transportation and mobility conditions in the city by promoting public safety on the streets and reducing the number of traffic accidents across the city. So this provides potentially positive urban health benefits, and maybe it encourages more equitable streets through encouraging walking, running, or biking. So as we can see from this traffic accident map over here, heat map over here, many of the streets, the city's traffic accidents happen along this kind of long stretch on Massachusetts Avenue, or Mass Ave as it's informally called. So say that we've been tasked by the city to scope out a hypothetical car ban on Mass Ave during certain hours of the week to make it pedestrian only. So they want us to select the best time and the best day of the week to make this happen, as well as scope out the potential impacts. Now, the standard traffic impact study looks at traffic volumes, patterns in peak hours, the distribution of trips, and travel modes. The bulk of these studies use manual and analog ways to count people and vehicles, or they have to install physical sensors on the road. But the bottom line is these methods are costly from a time, human, and financial resources perspective, and further, they don't scale very easily. So by the way, going forward, I'm going to refer to all vehicular activity, that being private cars, taxis, et cetera, as car activity, and all kind of walking, running, biking, et cetera, as pedestrian activity. So through the data and methods that we're presenting today, we want to answer some of the standard questions in a traffic study. For cars, we want to know how many trips currently go through the road, and thus how many vehicle trips we'd potentially be impacting. What's the trip trajectory of these vehicles? That is, where are the cars coming from, and then where are they going to? And lastly, who are the drivers that are going to be impacted? Now, this last question actually goes beyond a typical traffic impact study, I think. But with new data, we can estimate these characteristics. And in the spirit of promoting more equitable streets for the city, we want to make sure that we're not going to be making life more difficult for already disadvantaged groups. So for pedestrians, we want to answer a similar set of questions. How many pedestrians are currently on the road? Where are the pedestrians coming from and going to? And who are these pedestrians? This will give us both an estimate of who may benefit from this initiative and also help us understand how many more pedestrians we might see on Mass Ave if we find that pedestrians are coming from the neighborhood overall. And then lastly, as Mass Ave is a very commercial street, we want to understand the impact for the businesses there. So for the sake of time, I'm going to tell you that our hypothesis is that this initiative would probably positively benefit these businesses because it's encouraging more pedestrian traffic. The question is, can we estimate how much? And then furthermore, what kinds of businesses are we going to impact? So I should also mention that for the sake of time, we're only kind of looking at the first order impact of the car ban and not any of the secondary impacts on the other streets that might actually see more traffic as a consequence of this initiative. Okay, so we're building our analysis on an open source municipal data set. CARTO is an open source software company, and we fundamentally believe in and rely on open source data as foundational to our product and to our data science offerings. So our municipal data set is the Cambridge Police Department's traffic crash report data, which are these points in red over here. This is 5 years worth of data from 2010 to 2015. And this segment in blue over here is a section of Mass Ave between Harvard Square and MIT that we want to investigate. So now using this data, we want to understand what's the best day and what's the best time of the day to shut down the street to vehicular traffic. So using this crash data, I can look at which days have the highest number of overall traffic accidents. It looks like Friday just ekes out the other days, both in terms of the mean and the median for the number of traffic accidents per day. This chart here shows the accidents per hour for each day of the week. And it seems like the time between 2 and 7 p.m. in the afternoon consistently have the highest number of accidents on Friday. So with this information, let's look at the effects of closing down Mass Ave on Fridays between 2 and 7 p.m. So the next data set that we're going to bring into our analysis is new to the location intelligence world, anonymous mobile data or foot traffic data. And we hope to demonstrate in the next couple of slides that this kind of data can be both a powerful and a flexible tool. So first of all, why mobile data? There's a lot of background history here on the rise of information and communications technologies, but instead I'll try to stick to the essentials. Mobile phone usage is ubiquitous at almost 100% penetration in most developed countries. Smartphone penetration for adults in the US is about 77%. So because of the ubiquity of smartphones and the granular spatial temporal data that devices create, using mobile data as a representation of population mobility patterns has become increasingly interesting for location intelligence companies like CARTO. So now there are really important privacy concerns that we need to take into consideration when using mobile phone data, even if it comes anonymized to us. So as we go through this analysis, I'll be pointing out ways in which we can further anonymize and aggregate the original data in such a way that we protect privacy and also turn the original data into more meaningful and useful information. So some of you might be wondering whether this mobile device data is actually representative of the overall population, since not everyone has a smartphone. So in order to check whether we can use this data as a proxy for overall population, we compared it against census tract population counts in 2016, which is the most recent year for which there is data. Actually, it's American Community Survey data. So we can see that there's a pretty good linear relationship here between our mobile data and our census data. And this chart was just made using some pretty basic methods of comparison for the purposes of this demonstration. In our actual data offerings, the methods that we use to calibrate our data to census counts are much more advanced. So let's take a look at the MassAv data again. This is a map showing the original mobile data pre-aggregation. We've extracted the travel modes of our user pool along with travel speed and some initial temporal information. For instance, we can see here that we've already created the car and pedestrian travel modes, and we can already kind of see some patterns in the hours of the day and days of the week. But however, as it is now, we still don't actually have a count of the trips along Mass Ave. Now, here we joined the same data to road segments on and around Mass Ave. The thickness of the lines correspond to the number of trips we see on the segment every hour between 2 and 7 p.m. So as a side note, we might typically want to think about normalizing these numbers by the length of the road segments to get a density measure, but here I'm not doing that because I'm interested in just finding the pure total number of trips along the entire segment of Mass Ave. So let's see what's happening here. Using the mobile data, we're able to approximate vehicular traffic counts for 4 Fridays in the month of February by the hour. This chart is showing essentially the same thing. This chart is essentially a static version of this map over here. So for instance, we can see that the peak of volumes are around 5 p.m., which kind of makes sense because that's probably when people are commuting home from work. The pedestrian patterns appear quite similar. And so what do we gain from this information? We now have a dynamic estimation of the number of both pedestrians and car trips on the road, and thus the number of trips that we would potentially be impacting. So from these numbers, we can estimate that there are, on average, 7,800 pedestrian trips and 7,500 car trips per hour, which is about 125 car trips on the street per minute. That sounds reasonable and is in the right ballpark of the open data estimates that I found from 1994, which is unfortunately the latest year for which I could find open data. So while we love open data at CARTO, it's not always possible to get the right time and spatial selection that we need. So with mobile data, we can create and compare these slices with relative ease. So using these numbers, we now have an estimate of the number of cars we take off the road per hour and a gauge of the number of pedestrians who might benefit from the road closure. Now, let's take a look at where people are coming from and going to. The reason why we want to understand this is to get a sense of what kinds of trips we're affecting and which other roads are going to be directly impacted by the car ban. So the way that we find these larger effects is to look at the 2 hours before and after a trip along this segment of Mass Ave. So this map is showing us the same thing, the 2 hours before and 2 hours after trajectories of all the approximately 1,500 users that we saw along Mass Ave. And if you remember Andy's talk from yesterday, we basically showed the same data, but you can see that this map actually looks a little bit different from his Boston mobile data app. It's because every point on this map is someone who went through Mass Ave on Fridays between 2 and 7 p.m., and thus this map radiates out from Mass Ave. So we're able to see spatially the wider physical effects of a car ban, but what about who we're going to affect? And can we learn more about these users? Since we have data throughout the day and night, we can infer to the census tract level where people are at night and thus the general region in which they reside. This map shows a count of aggregated user residences joined to the US Census tract. We can see that overall, the drivers appear to be from much further away in a wider range of regions than pedestrians who appear mostly to be Cambridge locals. So it seems like a kind of obvious breakdown, but that's often what we want to do with our analysis, which is confirming the intuitive and the obvious. But I think that we can conclude something important, though, which is that the initial hope of the car ban was to encourage more pedestrians to use Mass Ave. If our analysis had found that all of our Mass Ave pedestrians actually lived in the suburbs, then it's probably unlikely that this car ban will do that much. However, as we found that the pedestrians who use Mass Ave are generally living around the neighborhood and the street, we can assume that the car ban would in fact directly encourage more pedestrian usage of the streets by the locals. So the next data set that we're going to bring into our analysis is census data. And despite the fact that this is one of the oldest and most standard data sets that people use, we want to show that there are new methods that we can use to understand census data from a novel and potentially more informative angle. So let's take a short detour from our case study really quickly. This is a population choropleth map for the greater Boston metropolitan region. This is how we typically see and map census data. And this is how we typically understand census categories, one at a time. By the way, these are the census categories for all of our Mass Ave users. Now, this information is helpful, but what if we combine these categories to create unique groups? I think it's easier to create narratives about different groups of people because it helps us understand and explain to others who we're impacting. So what if now we were able to create census maps that look like this? Here we've clustered our census categories based on similarities in the data. And we've actually written about a very similar method before, developed by researchers Alex Singleton and Seth Spielman. The categories that result are actually already part of CARTO's data offerings for the whole of the US, so this is not a process that you'll have to repeat yourself. Essentially, what we're trying to do is find these kind of bundles of category similarities. Here, I'm making a three-dimensional chart with 3 of our census categories: race, homeownership, and the number of kids on each of these axes here. And as you can see, the points within each group kind of gather together in the chart. So for instance, this green region here corresponds to that green blob over there. So what does this grouping or clustering give us? It gives us these very descriptive groups. We can intuitively understand, for instance, that a group of wealthy suburbanite white homeowners, like Group 0, makes a lot of sense as an entity. Similarly, Group 4, the middle-class urban renters composed of a mixture of races and without kids, also seems like a group of people that we recognize. And as a side note, this method, really importantly, also gives us a smaller margin of error in each of our census estimates than if we didn't group them. So we were able to break down our drivers and pedestrians to the different groups that I just showed. And we can see that our pedestrians are primarily composed of middle-class renters from diverse races who live in urban areas and don't have kids. And this makes a lot of sense since there are a lot of students and young professionals in the Cambridge area. And on the other hand, there's a significant chunk of drivers who are the wealthy suburbanites. And the rest, for both drivers and pedestrians, both have a fairly equal amount of kind of other upper-class middle populations. So we can see that our initiative will have a differential impact on our two groups. And the last example of a new data stream that I'm going to talk about today is MasterCard credit card data, which David Weiss at MasterCard yesterday gave a great talk about. I think this category of data is super interesting because it provides a new lens through which we can understand activity. We have mobile device foot traffic data to tell us how people move about and where they're going. And we have this type of data to help us understand what they're doing once they get there. Commercial activity makes up a large portion of how we can describe people, and now we have the data for that. So how can we use this data set in the context of our impact study? This map shows the locations of the venues from our Boston area data set, the points in white here. We've clustered these venues to find these kind of micro regions of commercial venues. OK, so here's where I tell you that I actually live in Cambridge, near the area of our study, which is partially the reason why I chose this area to do the analysis. However, understanding this area quite well, I can tell you that these groupings of microregions actually make a lot of sense. So we also know the industry category of each venue, which then allows us to look at the mixture of industry breakdowns in each of these clusters. What I'm showing here is the industry mix in each cluster of venues alongside the number of venues in each cluster. So this purple here is the restaurants and food establishments category, which kind of across clusters of all sizes make up about 25% of the clusters. So now going back to our impact study, recall that we want to understand the potential impact on local businesses. Here, we're looking at the business clusters alongside Mass Ave and their category breakdowns. And the size of the circles here represents the number of venues in the cluster. And this here shows where our pedestrians have stayed. The size of the circles here represents the number of stays within each kind of microregion. And very briefly, we are defining stay locations by a distance and time threshold. So any pings that are within both of these thresholds are kind of grouped together, and then the centroid of these points is marked as a stay location. So now we can start to kind of tease out the relationship between the number of venues a cluster has and how many points the cluster, or how many visits the cluster gets. And from this, we can create a multiplier of how much pedestrian counts will increase in each cluster. You can see that at 36 or so venues, we have about 100 visits. And this is a linear relationship on a logarithmic scale. Furthermore, and this is not something that we've shown here in the chart, but something that David talked about yesterday, is that we have a gridded data set of spend indices, which will then allow us to estimate the monetary value of how much revenues can potentially grow with increased visits to these areas. OK, so to do a quick recap, what did we just do, and how did we enrich our understanding? We started off with municipal data, which helped us narrow down our study conditions. We then used anonymized mobile data not only to count the number of cars and pedestrian trips on Mass Ave, but also to get a sense of where they're coming from and going to. We then layered census data onto the mobile data to understand demographic profiles, but through a new methodological lens. And we also used credit card data to see how businesses might potentially be impacted by this initiative. And there are other data sets that are part of CARTO's data stream offerings, such as events data and weather data, that would have given us even more different perspectives on this study. So this was kind of a simple example of a traffic impact study, but nevertheless, I was able to do this in a couple of days, by myself. No trip to Mass Ave needed. You can imagine the level of comprehensiveness that we can achieve with a little bit more time and effort. This compared to more traditional methods applied in traffic impact studies of manually collecting the data, but only for certain times and locations, means that we can create a fuller and faster understanding of our problem and solution space. So for businesses, again, that means money, time, and human resources saved. Further, for this traffic study, we added many more kind of useful dimensions of consideration than what is typical because we could with ease. In CARTO's data stream offerings, we've created an intelligent process of cleaning, modeling, and aggregating the data into a useful tool, as well as a streamlined data delivery through one source. Adding more layers of information can now happen much more readily. And lastly, I think we've demonstrated that these data sets can be very flexible and thus can be applied to many different kinds of sectors, from real estate development, perhaps using this data to describe neighborhoods, to retail and sales territory management, to healthcare through health and mobility analysis, to government and data-driven policy decisions. And why can we do all of this? Our new data streams and new methods give us this spatial specificity, temporal flexibility, and the ability to scale our analysis with ease to study anything from one road segment to an entire city or region. And where does CARTO fit into all of this? Going back to our cake analogy here, I'm really pushing the cake analogy. We have the tools and equipment in our software product offerings to bake the cake. We're the cooks in the kitchen with data scientists, engineers, and professional services support who are the experts in spatial data. And this is actually just a sampling of the different kind of spatial data science projects that we've worked on. And we deliver you the results, a data layer cake ready to consume. And lastly, with the beautiful maps that we make, we offer you the cherry on top. Thank you very much.